My name is Alan McCaskill, and I am one of the founder directors of Flotation Energy. What I'd like to do now is start to talk about who we are, and more importantly, about the Kincardine project, which is currently the world's largest floating offshore wind farm, and certainly for a number of years will have the biggest floating wind turbines in the world. We're a global leader in offshore wind development. We've got a track record in commercialising floating and fixed offshore wind. We're headquartered in Scotland, and we've got subsidiaries in Australia, Taiwan and Japan. The global team is 50, but it's rising rapidly. We are the company, or we are the team that developed the Kincardine project, which is the world's largest floating wind farm. And we were the first people to decarbonise an offshore wind platform using wind energy in the UKCS. Our team are developing commercial and demonstration sites in the UK and internationally. We're pioneering solutions to decarbonise oil and gas platforms in the North Sea and other places, and we're looking to alternative ways of monetising the project through other routes to the grid. Kincardine project, let me just talk a little bit about that. That project was something we started in 2013. The company was founded by Nicol Stephen, our CEO of Flotation Energy, and I, and a number of the staff in Flotation Energy worked with us on the delivery of that project. It's a 50 megawatt floating offshore wind farm. It's located 15 kilometres to the east of Aberdeenshire, and it's consented to have up to 7 turbines in it. Water depth at the site is somewhere between 60 and 80 metres, and we've currently got 5 by 9.5 megawatt Vestas V164 machines. We had a 2 megawatt for the first year, 18 months, to test drive and to learn about the site, but that was withdrawn as it was using up one of the export cables. We have a grid connection at a major to the south of the city of Aberdeen. We're going to have a life of about 25 years, and we finally got the project fully operational, delayed a bit because of COVID, but that happened in 2021. So let's talk about the actual substructure itself. It was designed by Principal Power, and it's fabricated in steel. It's a triangular semi-submersible substructure. The tower is located over one buoyancy chamber, 3 mooring lines in a fixed orientation into the prevailing wind direction. The turbine is installed onto the assembled substructure in port, and then it's towed, and operation occurs in semi-submersible mode. The maximum dimensions of this machine are a tip height of up to 191 metre and a rotor diameter of 164 metres. We've really got an opportunity here to be able to use this to test additional technology. And we're looking at a number of different areas. We're looking at new substructure solutions, whether those be semi-submersible, TLP, etc. We're looking at novel installation techniques which would allow us to install the turbines more effectively on floating substructures. We're looking at the potential for generation of hydrogen from offshore wind because of the proximity to shore, and particularly to the market for hydrogen that's being developed in the city of Aberdeen. We're also looking for offshore wind environmental monitoring technologies, and we have one of the largest data sets being compiled of bird data at an offshore site. The first machine with one system recorded 35,000 birds at that site. And we're going to test novel access systems in the floating environment, and we're looking to apply LiDAR technology to optimize the output. So what did we learn from the Kincardine project? Well, the first thing we learned is that the substructures must be designed to be stable at shallower depths in harbour and nearshore conditions. This is a good design, it's very useful, but for the future, its water depths in harbour conditions make it very difficult to actually integrate and to assemble it in UK East Coast ports. We also believe we need a modular design of substructure. Modules built in smaller yards, transported to an assembly yard proximal to site, and then put together the substructure, and then integrate the turbine, potentially at a different site, but close together, and to try to make sure that those sites are between 100 and 300 kilometers from the project site. We want to get to a world where we can basically see a weather window of a fully installed turbine ready to roll, take it out and moor it up in less than 48 hours, allowing us to install all year round. So those are the key lessons that we've learned. So let me now go on and talk just a little bit and show you a little bit about the activities we did, both in 2018 when we did the 2 megawatt unit, and later in 2020 and 21 when we did the bigger machines, fabricating and installing them. The picture you see here shows is the first 2 megawatt machine being assembled in the city of Dundee on the east coast of Scotland. And because it was the smaller machine, it didn't need the same water depth, so with a little bit of temporary buoyancy, we're able to do it locally. You can see there the turbine, the towers put on, the turbines put on, and then finally we put on the whole machine is integrated. This slide shows us leaving Dundee early in the morning, and a picture I always find interesting is to look at the little turbine there next to one of the world's biggest jackups, and our machine is taller. So there we are, moving out into the Firth, taking it out of the Firth and taking it forward to the just before we reach the edge of the Firth and into the sea, out of the estuary and into the sea. At that point, we took off the temporary buoyancy and prepared for tow up to the Kincardine site, which was about 12 to 15 hours away. In the future, for the bigger machines, we couldn't do it on the east coast of Scotland, so we had to make this a much longer tow. The machines were built in Navantia in Spain, transported on semi-submersible transporters to Rotterdam, where the turbines were integrated, and then transported from Rotterdam to site. What you see now here in this slide is the mooring going in 2018, but what you've got happening here is it shows you all the things that go below the water. You've got the anchors, you've got the clump weights, and you've got the chains. And these were pre-installed for all the machines on the seabed and were there waiting for us once we towed the machine to site. The next thing we see here is we obviously had to put the cables. We put the first cable in 2018 and we put the second cable in 2020. This shows the cables going in, and this is one of the closest I've ever seen as such a sophisticated vessel to the coast. We drilled a borehole from a field adjacent to the coast, came up out at sea, pulled in the cable through that, and then linked it to the pre-laid onshore cables, which took us all the way to the substation at the southern part of the city. Fabrication of the substructures. Here we see one of the substructures being put together in Navantia in northern Spain, and it occurred both inside in the halls and then outside in the yard. Buoyancy chamber is made. They're then brought together and they're put linked with the face across each side, and then eventually a third machine is brought there, a third buoyancy chamber, and they're all linked together. It's a long, slow process with the design of these machines, and that's why we believe in the development of a modularized design which will allow us to build the components in different places and then bring them to an assembly yard and run them through the yard, trying to deliver the objective of 50 plus machines in a year. So what you see here is the machines, 3 of them after they'd been built, they were waiting for transportation. They had to be transported from the assembly yard in Navantia to the integration hub in Rotterdam. Each machine had to go on a semi-submersible transporter and be shipped to Rotterdam. That took quite a number of days. It's about 1,500 kilometers. Once we got them there, we integrated them with the machinery and with the turbine, and then we ultimately towed it to site. But as you can see, each machine needs its own semi-sub transporter in order to get it there. Key lesson is you've got to try and make all of the assembly and ultimately the integration happen much closer to site. I think, as I said, our key lesson was 100 to 300 kilometers from assembly and integration to the site.